Hello, my dear students in grade 8. Again, we are in our second review session for the year 2019 for 2020, and we are still in our lesson, which is the powers. In this session, I'm gonna continue the objectives that we still have. We still have 3 objectives. I will discuss these objectives and hope you enjoy this review session. The seventh objective in our lesson is to recognize the form of any number written in scientific notation. Why do we use the scientific notation? As I said, the scientific notation is to write big numbers, very big numbers, and very small numbers in a simple way. So what is the scientific notation? To write a number in scientific notation, we should write it in the form of a times 10 to the power m. What's a? A is, we mean by a number which is between 1 and 10. It can be 1, but it cannot be 10. It can start from 1, but it should be less than 10. And m, the exponent, can be a positive number or a negative number, the exponent of the power of 10. For example, if we have 973, I first ask myself, 973, is it a number between 1 and 10? No, it's not. So we should make it a number between 1 and 10 using the point. If we use the point, we can write it 9.73. Now 9.73 is a number between 1 and 10. It should be multiplied by a power of 10. What's the exponent? The exponent is 2. It's positive because we have no zeros to the left of the number. Also 49.12, we should make it between 1 and 10. It will be 4.912, so we moved the point only one digit, so we wrote it as a power 1. 7 is a number between 1 and 10, so I should keep it 7. If I kept it 7, it should be multiplied by 10 to the power 0, as if I am multiplying it by 1 to give me 7, the same number. 29,0,0,0,0. I should make it a number between 1 and 10. First, I should split between the number and the zeros. Is 29 between 1 and 10? No. So I should make it 2.9 times 10 to the power 5. Why? Because we have 4 zeros and we moved it one digit, so we have to the power 5. Now the last example, 0.00008. Here the zeros are to the left of the point. So I ask, is 8 between 1 and 10? Yes, so I take it as it is. Now to know the exponent, because the zeros are to the left, so it should be a negative exponent. How can we know the 5? We count the numbers to the right of the point, 1, 2, 3, 4, 5, so it is 10 to the power negative 5. How can we write a decimal number in expanded form using powers of 10? To expand a number using powers of 10, we should multiply each digit according to its unit. How? If we start with the whole part, the first unit is the ones. So we multiply the ones by 10 to the power 0, tens by 10 to the power 1, hundreds 10 to the power 2, and so on. If we talk about the decimal part, we start with the first unit near the point, which is the tenth. So any digit in the tenth should be multiplied by 10 to the power minus 1. Any number in the hundredth or any digit in the hundredth is multiplied by 10 to the power negative 2, and any digit in the thousandths should be multiplied by 10 to the power negative 3. If I take this example, 48.071, I first start with the whole part, which is 48. Starting from 8, which is the ones, I multiply it by 10 to the power 0 plus 4 times 10 to the power 1 because it's in the tens, sorry. Now if we move to the decimal part, in the tenth we have 0, so we multiply the 0 by 10 to the power negative 1 7 is in the hundredth. We multiply it by 7 times 10 to the power negative 2. And in the thousandth, we have 1, so we multiply 1 by 10 to the power negative 3. Now, how can we apply the PEMDAS in calculations on numerical expressions, which are the order of operations as we talked before? If any numerical expression we have parentheses, exponents, multiplication or division, addition or subtraction, then what should be the order of operations? The parentheses are the strongest, then we go to the exponents, then we multiply or divide, at the end we add or we subtract from left. Suppose I gave you 19 minus 2 to the power 4. Here we have minus, which is the subtraction, and exponent. So exponent is the strongest, so I should get the answer of 2 to the power 4 first. So we write 19 minus 16 is equal to 3, and so on for the other examples. Now, how can we simplify fractions using rules of powers? This is very important, and while working, we should concentrate well, because any mistake makes all your work wrong. To simplify a fraction using rules of powers, we should decompose all the composite numbers in the base into prime numbers using the method of prime factorization. Then we apply the rules of power that we learned before. These are the steps of simplifying a fraction. As I said, first we should look for all the bases. If we have decimal numbers in the bases, we should change them into whole numbers. How? We multiply the number by a positive power of 10 according to how many digits we have to the right to get rid of the point. Then after that, we decompose all the composite bases into prime numbers using the method of prime factorization. For example, we have 49. 49 is not a prime number, so we should make the prime factorization of 49, which is we divide it by 7, it gives 7. If we divide by 7, it gives 1, so 49 is equal to 7 squared as prime factors. Then we should move all negative exponents to become positive. If they are in the numerator, we move them to the denominator, and if they are in the denominator, we move them to the numerator. For example, here we have 10 to the power negative 3 in the numerator. If I moved it to the denominator, it will become 10 to the power 3, and so on. After that, we should look at the numerator, and we should add all the same bases together using the rule, which is a to the power n times a to the power m equals a to the power n plus m. The same thing we do for the bases in the denominator. Now, after all, in this step, we should start reduction by canceling. How do we cancel? We look for similar bases. If they have the same exponents, they cancel each other. If they have different exponents, we will subtract the exponents.